All right, students, here we are. We are graphing f of x is equal to ax squared plus bx plus c. Now we have all of our letters. Now we have this in standard form, and so let's talk about everything that we've learned, and we can add to it if we'd like, take away, whatever. So the first thing I want you guys to do is go ahead and draw the outline. Make sure you leave some room. We are going to go over example 1, A and B. Example 2, we are going to graph based off the information, and then we're going to talk about maximum, minimum points, and we can also look at the graph of that. So we learned in 3.1 and 3.2 that if A is greater than 0, then we know it's going to open up. If it's less than 0, we know it's going to open down. We also know that the C value is the y-intercept. The AOS, this is what is new to us. There is a formula for the AOS. The AOS is x equals negative b over 2a. So here's your A, B, and C. Remember, these are coefficients. These are numbers. So let's go ahead and just draw just a graph that looks like this. This is our vertex. We should know that already. This dotted line is our AOS. Axis of symmetry. Remember, it cuts the graph into 2 equal parts. Okay. This point right here is our C value, or our y-intercept. Remember, it crosses the y-axis, so if this is your x-axis, here's your y-axis, so whatever C is, if you don't have a number for C, which is a constant, then we know that it's 0, it's going to cross at 0, okay? I think that's about it. It's opening up. Oh, our AOS is this. If you're given it in standard form, it would be x equals negative b over 2a. Okay, and another thing, the x-coordinate of the vertex is also negative b over 2a. So whatever your AOS is, that's the x-coordinate. Okay, so example 1, they're going to give us a function, and they're going to ask us to find the AOS without even graphing. Find the AOS, identify what your A, B, and C are, and then it's going to ask us to identify the vertex. This is going to be the starting point, step 1 and step 2, when we're going to graph in standard form. Again, it's standard form. So the first thing that we're going to do is take a look at finding the AOS. So I always like you guys to identify what your A is negative 6, B is 24, C is negative 20. Okay, our AOS is going to be x equals negative b over 2a. If b is negative, then make sure you have a double negative here. Don't just say, oh, b, well, let's just pretend b was negative. Don't plug it in there and say, oh, there's already a negative, I'm not going to attach the other negative. That would be incorrect. So what do? We just substitute. B is 24, so it's negative 24 over 2 times A. A is negative 6. So if we simplify, we end up with negative 24 over 12, which gives us, negative 12, which is positive 2. Okay, remember your AOS is a vertical line. It's that dotted vertical line, and that means that it's going to cross at a positive 2. So our AOS is x equals 2. Okay, so find the vertex. We're now going to use that 2. Our vertex is a point on the graph, but I do want to let you know that this 2 is the x-coordinate. So these numbers should match up. This is going to be our starting point. What we're going to do is we are going to find the vertex, and anytime we see an x, we're going to replace it with 2, and that will give us our y value. Okay, and so that's what we're going to do. So so we have a negative 6. We're trying to find our y value. So negative 6 times something squared plus 24 times something minus 20. And that something is that 2. So I'm going to replace the 2 here and here. Okay. This, I'm using this as a guide. And wherever I see an X, I'm going to replace it with 2. Okay. So I tried to show you substitution happening. You don't have to color coordinate these. I'm just showing you how I got that. Okay, so let's go ahead and use the rules of order of operation, rules of PEMDAS. 2 squared is 4. 4 times negative 6 is 24. Multiply these two and you get 48. So plus, sorry, it's negative 24. There's a negative 6 there. 48 and then minus 20. Bring down that 20. And let's go ahead and let's see, we have 24 and then add that to 2, which gives us positive 4. So 4 is here. So our vertex, or your V, is 2, 4. Okay. All right, let's go ahead and graph. We are going to graph, and like I said, step 1 and 2 are going to be what we did here. So I was preparing you, and your textbook does this well. Here's step 1, here's step 2. Graphing given in standard form. So here it is in standard form. The first step, step 1, is to find your AOS. Write that out. Find AOS. Identify your A, B, and C. A is equal to 3. B is equal to negative 6. C is equal to positive 5. Okay. And so in order for us to find our AOS, we're going to take our, we know that the formula is x equals negative b over 2a. Please write that out. Let's go ahead and substitute. Negative 6 over 2 times 3 gives us 6 over 6, which means it is 1. Okay, so remember our AOS is that dotted line. So I'm going to start building. My graph with the given information. So let's see. Oops. 1, 2, 3, 4, 5. 6. We'll do 1, 2, 3, 4, 5. Okay, so positive 1. It's going to be our dotted line. There it is right here. So I'm going to, this is my AOS. X equals 1. Dotted or solid line. Step 2 says find the vertex. Step 1, find the AOS, find the vertex. So just like what you guys did here in B, we're going to take that 1, that's going to be our starting point, and we're going to have to figure out what our Y value is. In order for us to do that, wherever you see an X, you're going to replace it with a 1. So I'm just rewriting it, replacing it with the 1. Figure out the math and go from there. So we end up with 1 squared, which is here, which is 1. And then 1 times 3 is 3. So let me just write down 3. And then here we have a negative 6 and positive 1. That gives me negative 6 plus 5. Go ahead and do the math, and you should have 3 minus 6 plus 5, which is positive 2. That 2 goes here. That's our vertex. This is our point. Okay, so that goes up here. So our vertex is 1, 1, 2. If you take a look at A is positive, so we know it's going to open up. Okay, our C value, do you remember what our C value means? Our C value is our y-intercept. So that means it should cross at positive 5. 1, 2, 3, 4, 5. Put a point there. Okay, that's step 3. I just did step 3 without telling you, sorry. Step 3 says find the y-intercept and then reflect. Okay, I'll talk to you about what it means to reflect in just a moment. So the y-intercept is, remember, it is a point. It's 0, 5. Or you can say y-intercept is positive 5, but we know on the y-axis it's going to hit positive 5. Okay, it talks about this reflecting thing. What does that mean? Think of a mirror. If the AOS was a mirror, we know that this point is how many units away from the AOS. It's 1 unit away, okay? So what you want to do is reflect this point off the AOS. So if it's 1 unit away, let's do it this way. If it's 1 unit to the left of the AOS, then we want to reflect that point, and that means it's going to be 1 unit to the right. Our second or third point, in this case would be our third point, would be 1 unit to the right, which makes it here. So this is a reflection. This it's reflecting off the AOS. So reflecting off AOS, which means that this point is now 2 up 5. It's 2, 5. So our new point. So we need at least 3 points to figure out, how our graph is going to look like. And that's all I'm asking is give me 3 points. Okay, but they have to be legit. You can't just say, oh, I feel like one's over here and the other one is being reflected. So again, we found our vertex. Okay, we use that. Found our vertex. We found out by looking at the equation that 5 is our y-intercept. We reflect it off of the AOS and we created 2, 5. So we have 3 points, and we can actually go ahead and connect. Make sure there's your graph. Okay. So I do want to mention this vocab word, maximum and minimum value. Maximum and minimum value, it is not the vertex, okay? It is the y-coordinate of the vertex. So if we were to look at, this function right here, this equation, then you can say, oh, in this case, it's our minimum value. This case, our vertex is the lowest point, so think minimum. Lowest minimum value. And it's our y-coordinate, which is 2. So we have a minimum value of 2. Okay? And so what we're going to be doing is we're going to be looking at an equation. We're going to find the vertex. We're going to do step 1 and step 2, which is find the AOS and the vertex and decide, is this a minimum or maximum value based off the graph. So that would be our last example. I don't know why I didn't write it down. Okay. So this is going to be example 3. And it will ask you something like, tell whether the function f of x is equal to negative 4x squared minus 24x minus 19 has a maximum, I'm just going max and minimum value. Okay. And so again, I'm going to rewrite this. F of x is equal to negative 4x squared minus 24x minus 19. Okay. So the first thing we need to do is find the vertex. I'm sorry, find the AOS. I know just by looking at our A value, I know that it's going to have a maximum value, but they want to know the actual number. Because this is negative, I know that my parabola is going to be U-shaped, but it is going to be reflecting down. It's going to be opening down. Therefore, this is the highest point on the graph, and that's why we know that there's going to be a maximum value. But we need to know what the y-coordinate of our vertex is. Okay, so step 1, we're going to find the AOS. Remember, it's x equals negative b over 2a. And we know that a equals negative 4, b equals negative 24. Those are the two things that we're going to use. So let's go ahead and plug it in. X equals negative 24 over 2 times negative 4. We have positive 24 over negative 8, and that gives us a negative 3. So we know that the x-coordinate of our vertex is negative 3. So we're trying to figure out what the y value is, what the y-coordinate is, and that will tell us what the maximum value is. Okay, so step 2. Find the vertex, which is negative 3. We need to know what that other number is. So we're going to take this negative 3 and we're going to plug it in here and here. Substituting. Remember that? So this is what it's going to look like. Negative 4 times a negative 3 squared minus 24 times a negative 3 minus 19. Okay. Here we end up with positive 9. 9 times negative 4 is negative 36. Multiplying. So I'm just kind of breaking this down. We end up with 72 and then minus 19. Left to right, go ahead and add, subtract. We end up with 17. So 17 is the y value of that vertex, but 17 represents the maximum value. That's the answer that we're looking for. Okay, there's your answer.